What are radians? Radians are a unit for measuring angles, just like feet are a unit for measuring length, and seconds are a unit for measuring time. To make sense of radians, let's start with a circle centered in a coordinate plane, and let's put an angle theta in that circle in standard position. Alright, now that angle theta spans a certain portion of the circumference of the circle. This arc we'll call S, and we'll also label the radius of the circle R. And what we can do is form the ratio of S and R, form this fraction dividing the length of the arc S by the radius of the circle R. And it turns out that that ratio is the definition of the radian measure for angle theta. Angle theta is the ratio of the arc length spanned by theta and the radius of the circle. Now the reason that this definition works is because no matter how big the circle is, if we compare the arc length spanned by that angle in the circle and the radius of the circle, we always get the same fraction. This ratio S over R is constant for that particular angle theta. Now if we make an even larger circle and compare S and R, we yet again get the same ratio. S over R is the same no matter what sized circle we have, and so we can use this ratio of S and R to define the angle theta. And this choice of definition for theta is really useful because both S and R are lengths. So it's the length of the arc S divided by the length of the radius R. So we're dividing two lengths by one another, and the length units cancel, and so radians become a unitless unit. They are pure numbers. It's a pure number that measures how big an angle theta is. Now another way we can consider what radians mean is to understand the definition from a different perspective. So let's again take a coordinate plane and put a circle in the center of the coordinate plane, and we'll put an angle, a specifically sized angle this time, in our circle. And this angle that we're putting in happens to span an arc length exactly equal to the length of the radius. So we're using an angle that spans an arc. That arc length spanned by the angle theta is exactly the same r as is the radius of the circle. And because the arc r is in the arc is the arc length, because that particular r represents the arc length, we can recognize it as being the S from our previous definition. And according to the definition of a radian measure, we compare the arc length with the radius. And since S is the same as R, what we're really doing is comparing R with itself, and that fraction, of course, equals 1. And so an angle of 1 radian, an angle that measures 1 radian, is an angle that spans an arc exactly the same length as the radius of the circle. And we could, in fact, have started with this as the definition of a radian, but these two ways of looking at the radians are consistent. They both lead us to the same place. Now once we recognize that 1 radian spans an arc of length r, we can contemplate what 2 radians must be. This must be the size of a 2 radian angle because it spans an arc of twice the length of the radius. And we can consider what 3 radians is equal to. We're almost halfway around the circle. We still have a little bit left to go. It turns out that little bit different, the little bit additional arc that we need to span to create a whole half circle takes us from 3 to pi. Pi radians is an angle that spans pi radii along the arc of along the circumference of the circle, where recall pi is a little more than 3. Pi is 3.14. And then we can see what 4 radians is. 4 radians will span 4 radii, an arc length equal to 4 times the radius of the circle. 5 radians will span an arc length of 5 times the radius of the circle. 6 radians takes us almost all the way around the circle, as we can see, but there's a little bit left over, and it turns out that what's left over is the difference between 6 and 2 pi. Again, pi is approximately 3.14, so 2 pi is approximately 6.28. So there's 6.28 radiuses that fit along the circumference of a circle. And this then leads us to the conclusion that the entire rotation around a circle, one full rotation, must be 2 pi radians. So that must mean that 360 degrees equals 2 pi radians.